Okay, we are live.
Okay, perfect. So we are live. Hi, everyone. Yes. Okay. Hello. Perfect. Okay. So once again, I welcome everyone to the session. And yes, good evening, everyone. Welcome to this exciting event on Be a Technical AI Agent Architect. I am Harshvardhan Singh, and it's my pleasure to be a host for this exciting event. Today, we have come together to explore what it means to be a technical AI agent architect with Lyzr Studio, a comprehensive environment that abstracts the complexity of large language models and vector databases to help you build intelligent, autonomous agents from the ground up. This session is designed for AI practitioners, solution architects, and engineering leaders who want. This session is designed for AI practitioners and solution architects and engineering leaders who want. This session is designed for AI practitioners and solution architects. So whether you're just beginning to learn about the large language model or you've already experimented with the thing, simple function call will leave with a clear blueprint for designing and deploying production ready agents. Over the next hour, we're going to learn a lot of things about AI and understanding about the LLM region. Over the next hour, we're going to learn leveraging vector data, understanding about RAG, and be covering best practices for prompt engineering, explore multi-agent architecture. So you can tailor your solutions for the complex work. Let's dive in and start building the future of intelligent responsible AI agents together. Without further ado, let me introduce you to the speaker of the session. And one second. Is it in lag? Without further ado, let me
Sorry, I think there is some echo. Yeah.
there's certain echo, right?
Yeah, there is certain echo. We might have to do this again. Nothing was audible. Everything was echoing. Yeah. Yeah, there is certain echo. We might have to do this again.
I think there's
Nothing was
echo,
audible. Everything was echoing.
from
Yeah, there is certain echo. We might have to do this again.
Akash. Can you
Nothing was
confirm?
audible.
Was there an echo that was going on? Akash, can you confirm? Was there an echo that was going on? Just a second, guys. Akash, can you confirm? I hope I'm clearly audible now. Let me check on the live as well. Hope I'm clearly audible. Check live as well. Hope I'm clearly audible. Check, check live as well. Okay. One second, guys. We're just facing certain technical issues. Let me adjust that, and we're going to get back with you. One second, guys. We're just facing. One second, guys. We're just facing. Is it better now? I think it's better compared to the past. I think we have fixed the issue. Is it better? Yeah, I think it's better. Okay.
No, no, I think it's still echoing.
Still echoing, right?
The output is coming again from your end. No, no, I think it's still echoing.
Everyone, I hope, is it better? Can anyone confirm? Everyone, I hope, is it better? Can anyone confirm? Everyone, I hope, is it better? Rasswanth, I guess we can start because we cannot delay this. We can skip this formalities then. Rasswanth, I guess we can start.
Sure. Um, I'm checking my mic. Is this all good from my end?
It looks good.
Yeah. If it looks good, yeah, let's get started. So let me share my screen and let's move ahead. And before that, I would call upon Vidur so that he'll set us context on what is happening, what are we talking about, and what will be the key takeaways from this session. So, Vidur, please go ahead.
Yeah. So hi everyone. I am Vidur and I have Rashwant with me, and we both will be taking up the session today. I'll just quickly brief about the topic that we have chosen about being a technical AI agent architect. uh, just sharing a bit more context, we at Lyzr, we are working with a lot of enterprises to drive AI adoption, to build AI agents and workflows for their use cases. And while we were having a lot of these productive discussions, we realized that there is a gap in the industry. It's not about learning AI, or it's not about how to deploy these AI agents. It's mostly about these enterprises not having the confidence to manage these AI agents, because we are at a stage where these enterprises realize that, okay, we don't have anyone in our company to understand the architecture of AI, or understand how these agents are working, understand what are these different concepts. So this gives us a very clear picture of how the role of software development, or how the role of AI development, product management is heading towards. And that is where we identify the role of AI agent architect, which is definitely going to be the role that enterprises are looking to hire for in the next 1 year or 2 years. So yeah, that comes from a lot of these discussions with some really top enterprises. We are working with some of the biggest banks of the world. We are working with some of the biggest airlines of the world. So we can definitely see the role of agent architect being the next big enterprise role. So that is why we chose this topic to discuss upon. And in terms of what we will be discussing in the session, I think we'll start from the very basic concepts of what are LLMs, how are they different from agents, what are vector databases. And yeah, before we go ahead, I would actually want a lot of you to enter in the chat that what is your background, if you are in college, if you are working somewhere, which college are you a part of, what is the goal that you're looking for by the end of this workshop, right? So that would give us a lot more context in how technically deep we can dive upon in this session. Yeah, that should be great. Yeah, as I was talking about, that we'll start from the very basics about talking about LLMs, vector databases, and we'll go very deep into connecting tools with these agents, talking about MCP servers, what is the need of guardrails and responsible AI in today's uh, architecture. So yeah, I think we are good to get started. Rashwant, I think we are good. We can get started with diving deep into the session.
Okay, thank you. Thank you so much for that. So, yeah, let's get started. Hi, I'm Rashwant, and I'm very excited that we're going to do this session together and let's learn. So, let's start by defining what technical AI agent architect is. So, if I could put it in a way, imagine you are a product manager, a backend developer, plus a DevOps engineer. So you go from defining the product, the tasks and requirements, go from building it and to actually deploying it. That is exactly how I would term the term technical AI agent architect, as someone who's comprehensive, someone who's got all of these skills. And trust me, it's not that hard with AI right here. So moving ahead, before we start, so this is Lyzr Studio, which is at studio.lyzr.ai, and when you sign up, you'll get to a page that looks something like this. And the best part is when you sign up, you will get 500 credits, and this will keep updating every single month. So you will have enough credits to play around, build agents, and actually make them work towards something right away. So keep moving ahead, and we will start from getting to the bottom of what made these agents that they are right now. The number one factor is LLMs, large language models. So basically, what are they? They are basically AI systems that are essentially very good at predicting the next word. So that is how they work. They just spit out the next word that is highly probable. And so why do they matter is because we need them, we need agents to make multiple steps. We need agents to make actions and do actions and think about what to do next. That is why we need these LLMs. And the LLMs that we use are really, really good and have gotten really good over the time. So imagine a year back we had GPT 3.5, and now we have GPT o4 Mini, for example, which can do reasoning, which, and take 4.0 for example, can do multimodal natively. So the AI LLM race has significantly moved ahead over the year, and with the tools used with multimodal, and reasoning capabilities, we can build much more complex and efficient agentic systems. So there are multiple types of LLM, starting with the most popular ones. We have GPT, Claude, and Gemini. These are really good ones that you can blindly trust and go for it and make sure they do the job right. And on the other hand, we have open source LLMs. These are, as the name suggests, cost effective, and so they are, built for being to made customizable, fine tune it, and make it modular. So this is the reason why open source LLMs exist, and they are very essential for the development of the entire tech itself. There's a very interesting language model that exists, which is small language models. These are examples, you can follow it in the screen, but their goal is to do one particular task, one set of tasks really, really good. Imagine you had a small language model just to write emails. That will be much better than a large language model doing that specific job. So you can fine tune it for that and get increased efficiency at the uh, you know uh, benefit of being small in size and faster in time. So, and the last ones will be the reasoning LLMs. So for example, DeepSeek, Quen, and GPT-o3, for example, are all reasoning models that not just give out content but rather think the output that giving and then go for the result after that. So moving ahead, vector databases. So what are vector databases? Basically, we see so much data around, basically image, audio, text, all of them, but all of them need to be computer readable. And so that we make embedding models. These embedding models take all this content, make them into vector embeds, and then store it in a vector database. So this is a way of transposing that data that you have, that content you have, and storing it as vectors, which is much more accessible by a computer, which is LLM in this case. This gives birth to a very interesting concept, which is retrieval augmented generation. A RAG under the hood needs a vector database, and you store all this data as vectors. And RAG is basically defining RAG as a technique that will improve your LLM's accuracy by fetching relevant information from your data source. This vector databases will help you fetch the exact vector by matching the vectors. You cannot match text right away, but you can match vectors, get the most accurate one, and return. That is exactly why vector database is important, which gives both a RAG, which will help you add more context to an LLM without the cost and time of retraining it. That is exactly why retrieval augmented generation is very, very crucial, and it's a very safe and sound alternative for retraining a model. Uh, Next comes prompt engineering. So it's very essential when you're trying to become an agent architect. It's very essential that you know how to prompt. The effective prompt is written in the structure that it's you can see right here, which will follow a goal and then return format and the warnings and the context. So think of it like keep the most important information at the top and then follow it with the next important one and then to the lower, and the most bottom one can be a very important information as well. So moving ahead, steps on writing effective prompts. The steps that Lyzr takes so that your prompts are very effective are these sets of parameters. You set a persona, you tell the agent what it is. Next, you give it a goal, what it should do. Next, you give the context, who are you? More like where are you from, what are you working as, so that it knows itself in terms. Then give it the task, what it should do, how it should do, what are the task it has to do, what are the steps it has to take, in what order. Next is the output, what should be returned, and an example. This is how we at Lyzr prompt our agents, and so this is very effective, and this will help in building amazing agents that perform really, really well. One functionality that I want to show in Lyzr Studio that we built that helps you do this really, really fast is when you go to studio.lyzr, when you go to an agent, you will find a prompt improvement agent. So imagine you, let's say, I have a tweet writer agent, and then the best part is that I could improve it, so I could write anything, really simple uh, text saying write a tweet, and when I click on improve, this is going to make it a fully fledged instruction that has all the necessary steps it has to take, so you don't have to worry about prompting. Next is the definition itself of what is an LLM and what is an agent. So let's take LLMs. LLMs are, you can think of it like water. They flow. They are, they don't have limits. They are very unstructured. And just like our mind wanders, LLMs are that. They flow. But on the other hand, take agents. Agents are defined to do particular set of roles, do set of actions, and think in a set of way. That is basically putting that water in a bottle, giving it a structure, and this structure will enable it to perform exactly how we want it every single time, make it consistent, scalable, and production ready right away. And this structure can be given by multiple things such as memory, such as triggers, tools, and orchestration. So that is something that I use to define what LLM agents are. And ultimately, agent contains LLM. That is why you have water in the bottle itself. So yeah, what is an agent? Defining it a bit more technically, they are autonomous agent act like set of entity that have a defined goal and use available tools to perform that and achieve that goal. So they are very different in everything else that we have right now is because they can reason on their own, take actions on their own. That is very essential for an agent to do. So, moving ahead, let's talk about how agents actually evolve. So, a couple of years back, which is when 3.5 was available, all that we had was to control the output that it generates is the temperature, the topic, and the messages you give. You didn't have much of control. But what is it? It is right now is that you have role, instruction, and the goal, and you have features. All these features are going to structure your water bottle uh, in that way so that it gives you exact output. a knowledge base, which is a RAG system, will get you exact content that you want to give it to add it. A memory module will enhance it to remember what it was talking about before. A humanizer and responsible AI modules, safe and responsible modules, are making it adhere to rules and make sure it doesn't go out of bounds. And that applies for groundedness and context relevance as well, so that it stays grounded. It does not spit anything that is wrong or not factual. Now, let's talk about a very interesting differentiation between agents and workflows. So, workflows are sequential, workflows are determined. So, you tell one particular entity to do something, give it to the second entity, and do something and to the third. This is you defining the sequence, and this definition will not change. But on the other hand, take an agent, you give it act tools, you give it memory, you tell it what to do, but it will determine what to do after one after the other. The steps it will do on its own. It will think, okay, hey, step number one is done. The output is good, so I'll go to step two. Or if the output is not as required, okay, I have to do step number one again, so I'll go back and do it. That is thinking, that is reasoning, that is the essential element of an agent where it can take decisions on its own. And this is a very efficient and very good read that you can definitely look up, is Building Effective Agents by Anthropic. There's a blog that I absolutely love and recommend. Do take a look and read it about how to build agents and what agents are. So let's talk more about, now we've covered a lot about a single agent. Now let's talk a bit more about multi agents. So what are multiple agents and why are they even needed if one agent is smart enough? The reason is that one agent, you should, it's best practice you do not overload. If an agent is going to write a tweet, it should only write a tweet. If it's going to write an email, it should only write an email. You should delegate your tasks to agents so that they don't get confused and give not so great results. When you split them into tasks, they give amazing results, and you can make use of them together and give your expected output. That is where multi-agent system comes into play. In the right, we can see what are the ways of designing a multi-agent system. And for example, a single agent is just an agent that has tools which will perform the tool calls necessary and give you the response. But on the other hand, take a supervisor. Supervisor is a manager, sort of an agent that is sitting there, that has access to sub agents, which determines how to use these sub agents efficiently. So again, that is that super agent making that decision while you have nothing to interfere and tell what to do. So these are two examples that I wanted to talk about, but there are multiple other ways you can design a multi-agent system. And it's, unless it's a simple task, it's always best practice to split your agents into multiple single sub agents and design a multi-system, multi-agent system. And something that I wanted to show on how to build that in Lyzr Studio is two ways you can build it. Number one is a workflow builder. This is the one that we talked earlier, where it is a sequential flow. So, for example, I have my resume, I have the job description, I will have an agent which will parse the URL and get the resume, fetch the JD for the job role, and evaluate if the candidate is good or not. And after that, it will schedule a meeting with that candidate. So this is a sequential flow. But on the other hand, there is an interesting flow which is a manager agent, which you can take here. You can see the same flow. I've built it in the manager style, where this is a super agent. I have sub agents, which is going to find the best candidate, generate the JD, extract criteria, and schedule the meeting. So this is that super agent that is going to delegate the tasks to each of the sub agents. And to enable it in the studio, all you have to do is enable toggle this manage agent button and select your sub agents and give them a description on what they're doing. This is as simple as it gets on building a multi-agent system in Lyzr Studio. Now let's talk about the core components of an AI agent. So of course, the number one component will be LLM itself. And something that I've been asked quite a lot is that how do I choose the right LLM for my agent? My best way to choose the right LLM is that number one, make sure you list down your actions or the tasks that it's going to perform. You have to ensure you know what you are making that agent to do. That is the step number one. And next, you go for the most accurate model or the best model out there and try and do that task with that agent. If it is working fine, great. We are done with step number one, and this is great progress. And after that is when we try to like bring down the cost and bring down the speed in terms of increase the speed. So then you switch models that are less costly and then faster and try and see if that accuracy is being matched. So you want to go for the most accurate one, get the results ready, done, working, and then try and optimize it further and further. Additionally, context window is also very important. You don't have to worry about context window if you're writing a tweet agent, but you should worry about if you're writing a blog writer agent, because context on how much it can generate is very important. Next is tools. This is the next important thing when you're building an AI agent. It is how do I ensure my agent has access to additional resources? What are additional resources? So types, these tool types could be data tools like a database access, a web search where it's fetching data. It could be action tools where it's performing something like a send email, like update in my CRM. Third can be agents as tools itself. So there could be another agent that will do a certain thing. You can delegate that to the particular agent and get that response and work with that. So these are multiple ways and multiple types of tools that is supported. And taking a look at how to configure those tools, you head out to studio and you go to the tools part. There are two types of tools that you can configure. The default tools. When you go to default tools, you can find all these straight out of the box available for you. And step number two, the tool type number two is adding a custom tool. Imagine if you don't have it here, what do? All you have to do is create a tool and give it that open API schema. Or if you want to use something that is not available, just fetch that endpoints open API schema and you're good to go. Imagine if you had that was sitting behind OAuth. You want authentication for that. It's as simple as adding a default header saying API key is ABC. So now your tool is connected, also authenticated. So it's as simple as that to connect your tools. And how do I connect this tool to an agent is when you go to your agent screen, you will find a tool configuration where you can select the tool and give it an action and connect it. It's as simple as that. And the best part is that I don't have to tell to make use of this agent, do this in this agent. My agent will determine on how to call that tool and what are the parameters that it needs. Now, moving on, this is a very interesting topic and one of the hot topics that in 2025 that we have, which is MCP, Model Context Protocol. So what is MCP? This is basically you have two entities, MCP client and an MCP server. So MCP server is one that serves tools. MCP client is someone that accesses those tools and performs or calls those tools accordingly. So for example, an MCP client is Claude Desktop. So I will show you a demo of how that works also. But yeah, so when you run through what is it essentially, it is basically your MCP server is sending or exposing your available tools to someone in a particular format, and the client can directly connect without any mapping of what to call what for. It's just as simple as that. Just no explanation needed, no definition needed. Straight away connect to it and gets working. So the key benefits of using an MCP server is it enables complex multi-turn workflows. You can do multiple things at the same time in a single workflow, and it's efficient using MCP. It ensures stateful, that is, the state at what it is right now is preserved. It's stateful. And thirdly, one of the most important reason is that error handling, logging, and retries. So your errors are logged properly and they're handled properly, and they are inbuilt retry mechanisms. And finally, yes, it makes your agents autonomous and production ready right away. So talking about the MCP architecture with a visual diagram, let's say you have MCP server, like let's say Gmail, Slack, and Calendar are all providing you MCP server, which is basically listing their tools. And you have an MCP client, which is in this case, let's say Claude. So this client can access these tools through the MCP server, and it does not have to do any sort of definition, any sort of manual work. You have nothing to do. Once the MCP server is connected, MCP client can directly access. So something that I want to show right away is that let's take Lyzr's MCP tool. This is available in Python pip package, and it's Lyzr MCP tool call. So doing a bit of brief on how to set this up, you have to install Python, you have to install UV, a package manager. All that is all you have to do. And you have to go to Cloud Desktop, and all you have to do is pass these two parameters, which is your Lyzr API key, which you'll find it in your studio, and user ID, which you'll also find it in your studio. So these are the two things that you have to fetch for from the studio and copy and paste this in your JSON in Cloud Desktop. This is the file, and that is all about it. Your Lyzr agents can be used as tools, and your Lyzr agent MCP server is set up. So to demonstrate what I mean by that is basically I've set up my Lyzr's MCP server, and you can see there are so many tools available. Let's say these are the 31 tools that I have. One of them is a agent that will answer questions about my bike. So let's say this is the question I ask. So this LLM does not have context on this information. So what does it do? It decides it will invoke a tool which has the most accurate description of doing this job proper. So it calls this bike agent, which is exactly the agent that will do this job for us, which is sitting in my studio. It asks this particular question, and that agent responds with the actual answer. And now my Claude has more context, it has the answer, and it just gives me the answer, which is two keys. So the beauty about using MCP server is I did not tell which tool to call. That is exactly why MCP servers are very important. I don't have to tell what it should call to get this information from. It did it on its own. And the most key thing to do this is that when you're building your agent, make sure your name and your description are super solid, that it exactly says what it's supposed to do. These are the two information that Claude uses to determine if I should call it this or call that or call the other agent. So I hope MCP servers and the use and the need for it is understood, basically how it makes your life simpler and eliminates any manual work from the user's end. So that is about MCP. And let's talk a bit more about guardrails and safe and responsible AI. So this is one of the key features of Lyzr's agents, which is responsible AI being built in the framework itself. What is responsible AI? There are so many cases where your response or your action could violate something. It could be making an harmful or an offensive suggestion, or something that is very biased, or even exposing someone's personal identifiable information, such as number, email, example, or passing that to the LLM. So there are so many cases where you can have something that could go wrong, and Lyzr has built a foolproof responsible AI solution built in. So taking a look at that, so you go here and you, when in this feature, you will find safe and responsible AI and hallucination manager. So when you click on responsible AI, this will take you to this page where you can configure your policies. So what is a policy? So your policy is something that you can define where you can tell what is good, what is bad, what is out of bounds. So I could say toxicity is point. So look for toxic content at the threshold is point two. And what is prompt injection? Where someone's saying, example, forget everything that you know, do this. That is a prompt injection where someone's manipulating the prompt. That can be protected as well, and you can set a threshold. And secrets are secret keys, for example, API keys and bearer tokens, API tokens that by mistake go to the agent or go to the user as response, that can be blocked as well. And you have allowed and banned topics. This can be topics that you don't want it to talk about or only talk about. So these are the two things that you can configure. Plus, this is keywords where you want certain keywords to be redacted or restricted, that you can add here. This is one of the most interesting part is PII redaction, where you can block uh, card numbers, phone numbers, SSN numbers, email IDs. These are personal information that could go to the LLM by mistake or go to a user by mistake. So you don't want that happening. If your data is much more valuable, you shouldn't let these go to anybody else. So it's essential that you block them, and Lyzr has an inbuilt feature that does it for you without any extra step. All you have to do is configure your policy and save it and go to the agent and add it. That's as simple as that. So doing a bit more, yeah, we basically saw what it does, and these are the ways that you can, stop it. And talking a bit more about fairness bias, reflection is fairness and bias is basically not biased towards a particular set of community. That is human nature, but you don't want an agent to do that, and no biases should be present. You should remove them if it's required. Reflection is after the output is generated, you go and do a validation check, seeing if the response is generated and the request asked are met. And groundedness is to check for all the facts that are true that you can add here. So you can add a fact here and then make sure that the agent is aware of that fact and does not misrepresent that fact. And context relevance is maintain the context of what it's talking about throughout the conversation. And additionally, there are two beta features, that is LLM as a judge and a panel, where you can create an agent and run automatic test cases, and LLM will act as a judge and see how accurate, how good your agent is performing. So these are the safe and responsible AI and hallucination managers that are inbuilt in the agent, and all you have to do is just one single click. So this is pretty much from my side in terms of covering topics. This is what I wanted to talk about. And
Rashwant, yeah. Yeah, can we also double down on how to create knowledge base and also the part about data connectors? When should we use a knowledge base and when should we use a data connector?
Sure, sure. Okay. Yeah. Now let's get a bit more into hands-on on playing with the studio and seeing what we could do with it. So, starting with knowledge base. Knowledge base is the RAG, the vector database of Lyzr. So, you can create a new knowledge base, and you can give it a name, description, and use any vector stores. So what are the available vector databases available here is you go to data connectors and you will find the these are the vector database, these are SQL databases, and you also have a graph DB. So these are the things that you can configure, and configuring is as simple as adding the credentials. You can view the documentation on how to add them. So once this is done, you can create a new knowledge base and then add your data. So for example, I have this bike rag, which is data, my knowledge base, and I have uploaded my user manual, which is what my uh, you know MCP server was calling. This is exactly the knowledge base it had. So when your knowledge base is created, you have three types of uploading data to it. Step number one is uploading a file. You can upload PDF, doc, or TXT, or you can crawl a website and get the website links, HTML, and URLs, and you can do that automatically by just pasting the website URL. And raw text, just text, anything that you want to type and upload. So these are the ways you can give more data to your knowledge base, which will in turn give you more context to the agent. So this, you can also test it out by uh, checking it here. So it will retrieve chunks and it will also show you what is the accuracy percentage of the retrieved chunk. So it retrieved something which is this particular text, which has an accuracy of 85.47, which is great. And you can also set your threshold on how, what is the bare minimum accuracy you want, how many chunks you want, and the retrieval types you want. So this is essentially how to create a knowledge base. And how to enable your agent to use knowledge base is you go to agents and you go to the agent, and this is where you configure it. You enable knowledge base and you click on the knowledge base that you created and save it, and that is it. So your knowledge base is connected to your agent, which is basically your RAG. You have a RAG functionality right now, and all you did was create a knowledge base, upload a couple of files, click single button, and choose the knowledge base. You're set. This is as simple as creating a vector database, vector store, adding data, and making sure an agent is using that. So this is one thing that I wanted to cover. And next thing is tools itself, which we covered a bit. And there is another type of data connector that we have. This type of data connector is for structured data. Knowledge base is for unstructured data. Let's say you have a large PDF. Let's say you have website URLs that have no particular structure. So you put all of them in knowledge base. But imagine you have a SQL database where everything is defined, everything is set properly. Now that is when you go to data connectors and you add SQL models. So Lyzr's agents can perform actions and read data from your SQL database and make use for that, using that and make that useful. So imagine, let's say we have added a Postgres SQL, or even simply you can upload a file which is CSV of SQL dump. You add that, you go to knowledge base, you click on create new, a semantic model, give it a name, uh, give it a vector store, and connect to a database and connect a documentation agent. If you don't have, you can create a new one. Documentation agent is basically to tell the agent what each field is. This will automatically understand what your SQL table data is, column is, rows are, and make that as a documentation and give it to your agent so that you just sit and watch it doing the magic. So once this is done, you can go back to your agent screen and click on data query and click on the semantic model that you want. So one thing with semantic model is that you can configure which one you're going to use. When you go here, you can see multiple tables that I have, and I can go into each of them and see what is the schema or the documentation created. So this is the documentation it automatically created, tells this uh, summary of the table, tells each column what it does and what is the type of each of the column. This is just that automatic agent doing it for us. I just watched it, and now I connect it to it, and then I give it a maximum number of tries it can do to find the rich, respective data. And generation time limit is basically it sending that query and retrieving that data from the SQL database, because connections might take time. So we give it a bit of a time. And this is one of the most interesting part, is that train the agent. So whenever this conversation is happening, your agent will automatically learn on how to call this uh, data next time. One SQL query might not work the next time, so it will learn on the go. And you have to just uh, select a temporary learning knowledge base where all the learning can go and sit, and that is about it. It will make use of it. So this is a bit about data connectors, and talking about bit more features as well: short-term, long-term memory, and voice. Short-term memory is if you're building a chatbot, you want it to have context that every single message is happening, and you can have context of up to 500 messages. That is short-term memory. Long-term memory, on the other hand, will summarize your sessions messages once in a while and make a summary and give to the, so that you don't have to worry about what happened 500 messages before. That is taken care of long-term memory, where you have the summary, you store the summary, and that stays. And voice agent, as the name suggests, you make this entire agent voice friendly. This is text friendly right now, you can test it out with text, but if you want to chat with it through voice, you just enable this one. Give it your 11 labs and deepgram keys, and then you select a voice, and then you're good to go. So this is about data connectors and uh, workflow builders as well. We talked about it, responsible AI, we talked about it. And something that is cool is agent marketplace. So when you go to agent marketplace, you can see Lyzr's agents that are built for use cases by Lyzr. And imagine taking sales. You have a cold email generator. You have a sales SDR that is going to outreach and sell your product. That is available. These are all available in the market. These agents, you can definitely play it out. And all you need is credits, and you have 500 credits the instant you sign up. And so yeah, that is about it from my side. Vidhu, would you like to cover a couple of stuff that you want to do, or anything that you would like me to cover?
Yeah, so we had a question regarding credit consumption. If the RAI modules would require more credits or would consume more credits, if you could just speak about that.
Yeah, so credit consumption. So basically, you head down to credit report to see what are the things that it consumed, what is the input, what is the output, how much credits in consumed, what model happened, all of them. So RA modules, if there is any additional check that is going to happen, would consume credits, but it's not going to be a really large number of credits that it's going to consume. As you can see in this entire demo, I did a couple of tries, and I've it's consumed only not even one, I guess. One credit was consumed. So this is how credit consumption works, and you don't have to worry about credit consumption for RAM modules. If the only thing you'll have to worry about, if you're using manager agents, if you're using multiple tool calls, or if you're using your agent to generate large text, because credits are depending on the input and output messages generated and how longer they are. So that is when you'll have to worry about how many credits are being consumed. But on the other hand, a good thing that is available by Studio is that you go to your agents, you click on need help choosing, you can see the most cost effective, time effective, and context wise sorted agents, plus not agents, providers and LLMs. And you can also see the special features that it has, such as reasoning, web search, anything that you would like. So you can pick what fits your use case, go for the best one, go for the, and then optimize further down to the optimal one. So this is a bit about credit consumption and picking the right models.
Yeah, so let me share my screen. We will quickly build an agent. So I can see a few comments regarding building an agent from scratch. I'll also show a Lyzr plus Lovable demo, which will, give a lot more context to the viewers.
Sure. Great.
Yeah, I'm hoping my screen is visible. So I think this can be an interesting 10 minutes if you give it some time and energy. So the good part about building agents with Lyzr or with any other platform for that matter, and having a workflow or sorry, having a front end connector like a Lovable or a Replit, this is where we can see the maximum leverage nowadays. This is where we can see the most interest coming nowadays. Let me share an example with you. For example, like recently we were having this discussion with some of our customers where we wanted to showcase them the ROI that they can get from deploying AI agents rather than their human workforce. So this is an interesting activity that I did where I built a full-fledged front end using Replit. This is a front end that I have built using no code. I have never used any coding. I'm not a developer for that matter. So I've built this through prompting using Replit. So we have a lot of these platforms like yeah, this is Replit. I can also show you some of the prompts that I used to build this app. So these are some applications that I was making. Yeah, so this is the calculator, and most of the conversation that I'm having with this Replit agent is all in natural language. For example, if you want to debug something, the sort of commands that I'm sharing with it, it is all in natural language, and it is building the front end for me. The AI part, where we can also see how to actually build an agent and launch the agent on Lyzr, is what we can do it on the studio part. So, for example, the problem statement for me is that I want to showcase our customers on how much ROI can they get. So I can name the agent on, okay, let's say we can call the agent as a human to AI ROI calculator. We can give it a description, it is optional. And because this is a higher reasoning use case that I want to showcase, so I'll be using a higher reasoning model, which is GPT-o3. We have a lot of models you can choose from. Claude, I think Sonnet 4.0 also works very well for this use case. Why I have chosen a higher reasoning model? Because there is a calculation involved. When we want to showcase an ROI, there is a lot of mathematics that I'm expecting the LLM to do. So I need a higher reasoning LLM for this. We have defined an agent role where you are an expert ROI calculator. You have to help businesses understand the cost savings. I've explained the task. And then I have also explained it in detailed instructions that these are the fields that you will be getting from the user. A user will tell you the annual compensation per employee. The user will tell you number of employees, the job description, what are the day-to-day activities required for that role. This is what you will get as input from the user, and you have to calculate the ROI based on these inputs. Like if we want to replicate the same action through an AI agent built on Lyzr, how will that look like? How much will you save, and what will be the workflow for that? So this is a detailed instruction. Of course, I've used ChatGPT to write the prompt itself, which is another use case. And then this improve prompt feature always helps me. Another addition that I did was we also want to show that how will this workflow look like for you? How will it visually look like? What are the number of agents involved? And we already have a lot of blueprints for a lot of these use cases. For example, if you want an AI agent who will send emails on your behalf or who will call your customers on your behalf, so we have some workflows built. So I created this knowledge base which exists of all the blueprints. So I've named it as existing blueprints. This is all the data that we already built manually, and I've added it as knowledge base. Why did I need a knowledge base? Why did my prompt itself cannot do all the job? It can, and it does pretty well. But adding the knowledge base gives it a lot more relevant context. For example, if it was drawing workflows in a very random fashion and we want our workflows to be drawn in a very specific manner, so attaching this knowledge base enables that for the agent. The good part is that I took the agent API here, I took the agent inference here, and I just pasted this inference into my front end agent. And this is what my agent, this is what I was the front end that I came up with. That a user can select the role, the user can enter roles and responsibilities, the user can enter the annual compensation, the number of employees. And once you calculate savings, we are calling Lyzr's API in the backend. And when the API is being called, I'm getting a JSON response, which ultimately turns my website response into this. So we have a calculation here. We even have some workflows built in this. So yeah, this is the scope of what all we can do, like having a front end built on a lovable or a replit. This is also a good fun project if you are wanting to make a prototype, if you are participating in a hackathon and you want to give a good front end to your AI agent. You can definitely build it on using no code, and you can simply connect Lyzr's APIs with that. So yeah, I think this is a great way to have a backend built on Lyzr and a front end powered by any of these website builders, and actually have an end-to-end application in front of your eyes. So I think this is pretty much it, what I wanted to share. I think, Rashwant, thanks for having that session. We will go through some of the comments that we have. I think we have covered most of them. Yeah, I think we're good to go. I think if we have someone from Geeks for Geeks team who can take this over from here.
Okay, so that was it. And to be very honest, it was an amazing session that I really, really learned a lot. So thank you, Vidur and Raswant, for this amazing session. I'm sure as I learned from it, definitely the audience also learned a lot from it. And the theoretical portions that were very insightful, we got to learn a lot about the RAG and how it is actually implemented with your solution and how it is actually helping us. And the best part that I felt was the token system that he provided us. So I guess my job for today is to go after this and try out those new functionalities and use those credentials. And I hope that's a task that you guys are also doing in the same. So let's see if we have any questions. I guess as Vidur mentioned, all the questions were already taken care of. So with that, again, what's left to say is to just try out those credentials and try to utilize them to your maximum. And that's it. That's it, guys. Thank you so much for the set. Thank you so much for this amazing session. Again, you guys are in the spotlight. Thank you, Raswan. Thank you, Vidar, for this amazing session. And I hope they have the link to check that. Yes. So everyone, you in the description box, you have the link to check the studio. So do check that out. Okay. And after the session, also we're going to drop that in the description as well. Okay. So again, thank you everyone, and we'll see you in the next one. Raswant and Vidhu, do you have any final words? Want to say anything to the audience?
No, we are good. Thank you so much for joining, guys. I hope you got a lot of value from this.
Yeah, thanks for joining. We just expect that you guys try this by yourself. I think we have tried to keep it as hands-on as we could, but the real learning would come from trying it itself. Yeah.
Perfect. With that idea, we'll end the session. Thank you everyone, and I'll be see you in the next one. Okay. Thank you. Bye.
Thank you.